How is kinetic energy used in real-world problems? Imagine a roller coaster climbing to the top of a hill, then racing down at incredible speeds. That rush of motion is a perfect example of kinetic energy in action. Kinetic energy is the energy an object has because it is moving. It is a key part of many everyday situations and technological processes. Understanding how it works helps us see how motion and energy connect in the world around us. Vehicles like cars, bicycles, trains, and airplanes all depend on kinetic energy to move. When a car speeds up, it gains kinetic energy. When it brakes, that energy is often turned into heat through friction, which is a basic principle in thermodynamics. The faster or heavier the vehicle, the more kinetic energy it has, which influences how much energy is needed to start or stop it. Kinetic energy is also vital in generating electricity from natural sources. Wind turbines turn when the wind blows, converting the wind's kinetic energy into mechanical energy. This motion spins the turbine blades, which then drive generators to produce electrical energy. Similarly, hydropower plants use the flowing or falling water's kinetic energy to turn turbines, creating electricity. These processes show how kinetic energy from nature can be transformed into usable power. In factories and industries, machines like drills, saws, and presses use kinetic energy to perform tasks. The moving parts of these machines have kinetic energy that helps cut, shape, or assemble materials efficiently. This use of kinetic energy makes manufacturing faster and more precise. People are also harnessing kinetic energy in new ways. Wearable devices can convert the motion from walking or running into electrical energy. This technology reduces the need for batteries by capturing energy from everyday movements. It's a clever way to turn motion into power right from our bodies. In sports, athletes use kinetic energy every time they run, jump, or throw. Analyzing how motion transfers energy helps improve performance and safety. For example, understanding impact forces during a jump can help design better sports gear to prevent injuries. Kinetic energy plays a role in safety as well. Roller coasters relying on the balance between potential energy at the top and kinetic energy during the ride. Engineers use calculations of kinetic energy to design crash barriers and protective gear that can absorb impact forces, keeping people safe. In the world of heat transfer and thermodynamics, kinetic energy is linked to the microscopic motion of particles. When particles move faster, the temperature rises and heat energy increases. Friction and collisions convert kinetic energy into heat, showing how energy transforms from motion to heat. This principle helps explain how engines work and how heat is generated in many systems. Overall, kinetic energy is a fundamental part of solving real-world problems involving motion, energy transfer, and mechanical work. From powering our homes with renewable energy to designing safer vehicles and sports equipment, understanding how kinetic energy works helps us improve technology and everyday life.